Physics, Science, Paper 1, 2021 exam. So B1, figure B1.1 is a diagram showing the reading of the vernier caliper. So what is the reading shown on the vernier caliper? So the reading here, we are going to start with the main scale. So when you are getting the reading on the main scale, you don't need to go beyond this 0. So you have to say this is 5, 5.1, 5.2, 5.3. So we have 5.3 on the main scale. 5.3. Then on the vernier scale, you have to get the reading on the consigned line to 2 decimal places. So the consigned line, this is the consigned line. So where the upper line and the lower line, they are intersecting. So this is a consigned line. This is where we need to end. So this is 0.00, 0.01, 0.02, 0.03. So 0.03. Then we add. So when we add, we are going to have 5.33 centimeters. Then the B1 is convert the reading in A above to meters. So remember that 1 meter is equal to 100 centimeters. So we are converting this centimeter to meters. So 5.33 centimeters to meters, you put x there. From there you cross multiply. So you're going to have 100x is equal to 5.33 over 100 over 100. 100 goes. X is equal to, the answer is 0.0533. So 0.0533 meters. So that is our answer. B2, write the reading in B1 in standard notation. So in standard notation, so we have to move this point between 5 and 3. So it is going to move to 1, 2. So it is going to be 5.33 times 10 to the power. When we are moving from this side, going this side, it is going to be negative. So the point has moved to 2 places. So it is going to be negative 2 meters. So that is our answer. Then 3, how many significant figures does the vernier caliper reading in meters have? So how many significant figures does the vernier caliper reading in meters have? So this is in meters. So zeros at the beginning, they are not significant. So in this case, we have 1, 2, 3. So we have 3 significant figures. B2, a man of mass 75 kg on Earth goes to the moon, where the gravitational field strength is 1.6 newtons per kg. What is the mass of the man on the moon? So remember that mass does not change. Mass is the same. So this man at 75 kg on Earth. So when he goes to the moon, the mass will be the same. It will not change. So the mass is still 75 kg. Then B, what is the weight of the man on the moon? So the formula for weight is mass times gravity. So mass of the man on the moon is 75 kg times gravity. So gravitational strength on the moon is 1.6. So gravity is 1.6. Weight is equal to 75 times 1.6. So the answer is 120. So we have 120 newtons. Part C, a light truck of mass 2000 kg accelerates from rest at a rate of 1.5 meters per second squared. Calculate the force required to accelerate the car at this rate. So the formula that we are going to use is force is equal to mass times the acceleration. So mass is given to be 2000 kg and acceleration is given to be 1.5. So force is equal to 2000 times 1.5. So force is equal to 2000 times 1.5. The answer is 3000 newtons. That is the answer. B3. B3.1 is a diagram showing a uniform meter rule freely pivoted at its center. So this is its center. A Newton meter is hung 20 centimeters from the pivot, while a 4 newtons weight is suspended 40 centimeters from the pivot. So this is 4 newtons, 40 centimeters from the pivot. This is the pivot. Then 20 centimeters from the pivot. That is the Newton meter. So now the first question is, the meter rule is in equilibrium, meaning it is balanced. State the principle of moments for a body in equilibrium. So for a body to be in a rotational equilibrium, the sum of the clockwise moments is equal to sum of the anti-clockwise moments about a point called pivot. That is principle of a moment. Then part B, calculate the reading on the Newton meter. So the reading on the Newton meter. So for us to calculate the reading on the Newton meter, we need to use the principle of a moment. So where we have force 1 and distance 1, we have force 2 and distance 2. So in this case, these 40 centimeters and 20 centimeters, they must be converted to meters. Force 1 given is 4 newtons times distance 1. From 4 newtons to the pivot, it is 40 centimeters. So it will be 40 over 100 equals, force 2 is what we are looking for, times distance 2, it is 20 centimeters. It must be converted in meters. So the reason why I'm dividing with 100, I'm converting from centimeters to meters. So there we have, so this is 1.6. So we have 0.2 F. So from there I'll divide throughout with 0.2. 0.2. So F is equal to 1.6 divided 0.2. So the answer is 8. So 8 newtons. Part C, state with a reason whether the Newton meter reading would increase or decrease when the 4 Newton weight is moved to a distance of 30 centimeters away from the pivot. So now let us start by calculations. So 4 newtons. So it will be 4 newtons. We are going to use the principle of a moment. So if 4 newtons is moved to a distance of 30, so it is going to be 30 over 100 equal to, okay, whether the Newton meter reading will increase or decrease. So force on the Newton meter times, we will maintain the same distance there, which is 0.2. Okay, so this is 0.2 here. So 0.2. I'm going to have 1.2 is equal to 0.2 F. So over 0.2 over 0.2. So F is equal to 6 newtons. So here we add 8 newtons. Here it is now 6 newtons. So the Newton meter reading, it will decrease. It will decrease because the anticlockwise moment, it has what? Reduced. So in this question, the anticlockwise moment was 1.6. In this one, the anticlockwise moment is 1.2. It has decreased. We expect the Newton meter reading to decrease as well. Number 4, a small earth ball of mass 0.14 kg is thrown vertically upwards and reaches a height of 12 meters above the point from which it is thrown. So A, calculate the work done in lifting the stone to the height it attains. So work done is equal to force times distance. So do we have force? There we don't have. Okay? So remember that work done is the same as potential energy. So potential energy is equal to force, which is mass, times gravity, times distance, which is height. So work done and potential energy, they are the same. They've got the same formula. So work done is equal to mass is given to be 0.14 kg times gravity, it is 10. So gravity, it is 10. So remember that it is going vertically upwards. So vertically upwards, it must be negative. Okay. So now there is no work done, which is negative. Then the height is 12 meters. So work done is equal to 0.142 times 10 times 12. So the answer is 16.8 joules. So this is the work done. Part B, what is the velocity of the ball at the maximum height? So we have this formula. Velocity squared is equal to initial squared plus 2ax, where x, it is the displacement or the distance. So we are looking for velocity squared. So we are looking for velocity. So initial velocity, remember that initial velocity in this case, it is 0. Okay? So it will be 0 squared plus 2 times acceleration. It is going to be 10. Okay? So which is acceleration due to gravity. It is going to be 10 times displacement that we have, which is the height. It is 12. So velocity squared is equal to, so 0 squared plus 2 times 10 times 12. So the answer is 240. So for me to find velocity, I'll introduce the square root. So velocity is the square root of 240. It is 15.5. Alternatively, we can use this formula for kinetic energy. So where we say that kinetic energy is equal to 1 over 2 mv squared. So remember energy conservation. Energy conservation, it states that energy cannot be destroyed or created, but it can only change from one form to the other. So if this is the potential energy, according to energy conservation, this potential energy to be converted to kinetic energy, which is 16 0.8, 1 over 2. So the mass given in this question, it is 0.14 times v squared. So from there I'll say 16.8 is equal to, so the half of 0.14, it is 0.07 v squared over 0.07 over 0.07. So this goes. We have velocity is equal to 0.07 into 16.8. It will give us 15.5 meter per second. So that is velocity. Part C. On a wind day, the same stone is thrown upwards with the same energy but fails to reach the height reached earlier. Why does it happen like this? So on a windy day, so remember that there is so much wind. So when we throw a stone, so you'll find that it will experience some air resistance. It will experience some air resultant, reducing height and what? Velocity. So number 5, figure B 5.1 shows transverse waves. So this is the wave that we have. So the distance of the wave is 6. The displacement is 5. So part A, find the number of waves in figure B 5.1. So how do we count the number of waves in this case? So this is where the wave starts and this is where it ends. So this is number 1, number 2, number 3, number 4, number 5. So in this case, we have 5 waves. So this 6, it is the distance of the wave. So part B, what is the amplitude of the waves generated in the figure above? So the amplitude of the wave, that is the maximum displacement a particle reaches from its resting position. So from this is the resting position. So from here to there, it is 5 meters. Part C, calculate the speed of the waves above. If the number of waves in figure B 5.1 are produced in 2 seconds. So there, the formula that we need to use is speed is equal to distance of the wave divided by the time taken. So the distance of the wave, it is 60 meters. And the time taken, it is 2. So 2 into 6, it is 3. So 3 meters per second. So number 6, figure B 6.1 shows light in air striking the vertical side of a rectangular grass block at an angle of incidence 60 degrees. So this is the diagram that we have. So the refractive index of grass is 1.6. What is refractive index? So refractive index, it is the ratio of the speed of light in a vacuum to the speed of light in a what? In a medium. Or we can simply say it is the ratio of the sine of the angle of incidence to the sine of the angle of diffraction. Then B1, calculate the angle of refraction. So remember in this question that refractive index is given to be 1.6. And the angle of incidence is given to be 60. So refractive index is equal to sine I over sine R. So refractive index is 1.6 Angle of incidence is 60 over sine r. So sine 60 is 0.866. So we are going to have, so 1.6 times sine r, it is 1.6. Sine r is equal to 0.866. That is sine 60. So over 1.6 over 1.6. So sine r is equal to 0. So for us to find the angle there, we are going to introduce the sine inverse. So sine inverse, so angle R, which is the angle of refraction, is equal to shift sine 0.54126. The answer is 32.8 degrees. So that is the angle of refraction. What is the critical angle of the grass block? So the critical angle is given by this formula. Refractive index is equal to 1 over sine of the critical angle. So refractive index is given to be 1.6 is equal to 1 over sine of the critical angle. So I'll cross multiply. So we have 1.6 sine of the critical angle is equal to 1. So over 1.6 over 1.6. So 1.6, 1.6 goes. So sine of the critical angle is equal to 1 divided by 1.6. So there it is 0.625. So I'm going to find the inverse function. So shift sine 0.625 equals 38.7 degrees. So critical angle is equal to 38.7 degrees. Number 7. A. Explain what is meant by magnetic field. So magnetic field, it is the area around a magnet where a force can be felt on another magnet or magnetic material. So that is the magnetic field. Then part 2, electric field. So the electric field, it's a region of space in which an electric charge experiences an electric force. So electric field, it is a region of space in which an electric charge experiences an electric force. Part B, complete the diagram in figure B 7.1b to show the pattern and direction of the magnetic field lines in the space around the bar magnet. So this is the magnet that we have. So now to show the pattern and the direction of magnetic field lines, remember that the magnetic field lines, they move from the north pole of a magnet, which is this one, to the south pole of the magnet. So this is how it will be. So the magnetic field lines from the north to the south, 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 from the north to the south. Also from the north. So that is the way it will be. Part C, figure B7.1c shows a positively charged sphere S placed near to an initially uncharged isolated conductor AB. Complete the diagram to show the charges induced in the diagram. So for S, this is positively charged sphere. Then this is uncharged. It is uncharged. So meaning if it is uncharged, then this is what it means. So this is the uncharged isolated conductor. So when they say uncharged, this is how it is. So it has the positive charges and the negative charges. So when it is near the positively charged sphere, so these positive charges, they will attract the negative charges of this conductor. So the negative charges, they'll come this side. And the positive charges, they'll go this side. So this is the positive charges. So this is how it will be. Number 8, figure B8.1 shows an electric circuit containing two resistors. So we have two resistors, resistor 1 and resistor 2. So this is a battery which is 16 volts, and we've got the switch and the ammeter. So part 1 on figure B8.1, draw on the circuit to show how a voltmeter will be used to measure the potential difference across the 6 ohms resistor. So now, how do we draw on the circuit the voltmeter which will be used to measure the potential difference across the 6 ohms resistor? So the voltmeter is always connected in parallel with what it is measuring. So in this case, we want to measure the potential difference across 6 ohms resistor. So the voltmeter, it must be parallel. So this is what it means. So this is the symbol for the voltmeter. So this is the answer. If it was 6 ohms resistor and 2 ohms resistor, would have covered the all of this. Part B, when the switch is closed, calculate the current through the ammeter A. So current, it is given by this formula, voltage over total resistance. So current is equal to, so the voltage, it is 16 volts. Then total resistance, remember that these two resistors, they are in series. So how do we calculate resistance in series? So we say total resistance is equal to resistor 1 plus resistor 2. So total resistance is 6 ohms plus 2 ohms. So total resistance is 80 ohms. So the total resistance, it is 8. So current is equal to 8 into 16. So that is 2 amps. So then part C, what is the potential difference across the 6 ohms resistor? So potential difference, that is voltage. So remember that current is equal to voltage over resistance. So you need to understand that current in series is the same. So current here, it is 2 amps. So the current that is passing through here, it is the same in the series. So current is the same at 6 ohms, current is the same at 2 ohms. So if it is 2 amps here, it is 2 amps there. So current is the same in series. So our current is 2. So current, it is 2. Voltage is what we are looking for. Then resistance, remember that it is 6 ohms. So 2 times 6, it is 12. So 12 volts. Number 9. Uranium decays to form a nucleus of thorium by emulsion of an alpha particle. Thorium has the symbol. So this is the symbol for thorium. So what is the meaning of nucleon number? So nucleon number, it is the sum of protons and neutrons in the nucleus of a particular atom. Or in other words, it's a total number of protons and neutrons in the nucleus of a particular atom. So part 2, write a decay equation to show how uranium decays to thorium after emitting an alpha particle. So now, remember the general equation. So this is A, this is Z. So when this element emits an alpha particle, remember that the mass number decreases by 4. The proton number decreases by 2 plus helium. So this is what is going to happen. So remember that it is uranium which decays to thorium. So we have uranium. So uranium, it will decay to thorium. So remember that 8, it will decrease by 4. So you have to subtract with the 4. So we are going to have 234. Then 92, it will decrease by 2. So we are going to have 90 plus helium. So that is the equation. Part C, thorium decays to an isotope of protactinium by beta decay. Write the equation to show this process. So the general equation for beta decay, I have X, A, Z. So when it undergoes beta decay, the mass number remains the same. Then the proton number increases by 1 plus C, the symbol for an electron. So this is what is going to happen. So thorium, it decays, it undergoes beta decay. So the mass number, it will remain the same. So we have 234. Then the proton number increases by 1. So we're going to have 91 plus. So this is our answer. C1, figure C1.1 shows a conveyor belt driven by an electric motor carrying suitcases into trailer of a truck. So this is a motor and these are suitcases. And this is the truck. And now we have this distance, this distance. So part A, give two differences between mass and weight. Number one difference of mass and weight is that mass is constant, it does not change. Okay? Mass is constant. That's number one. Weight, it varies. Then number two, mass is measured in kilograms. Weight is measured in newtons. So when we want to measure mass, we use an electronic beam balance. When we are measuring weight, we use the spring balance. So part B, if a suitcase of mass 20 kg is lifted from the ground to the truck, taking G as 10 newtons per kg, calculate the weight of the suitcase. Weight of the suitcase. So weight of the suitcase is equal to mass times gravity. So weight is equal to, remember that mass of the suitcase is 20 kg. So 20 kg is the mass of the suitcase, then gravity is 10. So 20 times 10. So weight is equal to 20 times 10. We have 200 newtons. So that is the answer. Part 2, calculate the gravitational potential energy of the suitcase at the top of the conveyor as it enters the truck. So potential energy is equal to mass times gravity times height. So potential energy is equal to mass is given to be 20 times gravity, it is 10, times the height. So remember that we have two heights. We have 9 meters and we have 6 meters. So here we are looking at the energy of the suitcase. So the height of the suitcase, it is 6 meters. So 6 meters, it is the height of the suitcase. So this 9 meters, it is the height of the effort. So height, it is 6. So potential energy is equal to 20 times 10 times 6. So what we are going to have is 1200 joules. Then part C, the suitcase takes 12 seconds to travel 9.0 meters along the conveyor belt. Calculate the power of the motor. So power is equal to work done divided by time taken. So remember that the work done, it is the same as the potential energy. So the potential energy is 1200 joules. So work done, it is 1200 divided by, remember that time, it is 12 seconds. So divided by 12. So power is equal to 12 into 1200. We're going to have 100. So we have 100 watts. Part D, the electric motor is powered by an input voltage of 230 volts and current of 1.5 amps. Calculate the electrical energy input to the motor in 12 seconds. So electric energy is equal to power times time taken, voltage and current. So voltage is 230, current is 1.5, time it is 12. So electric energy is equal to power, it is voltage times current. So where there is power, we substitute voltage and the current. So electric energy is equal to voltage is 230 times current is 1.5. Time, it is 12. So electric energy is equal to 4140 joules. C2, figure C2.1 shows a square block of glass JKLM with a ray of light incident on side JK at an angle of incidence of 60 degrees. The refractive index of the glass is 1.50. So that is the diagram that we have. Part A, calculate the angle of refraction of the ray. So refractive index is equal to sine I over sine R. So this is the angle of incidence. This is the angle of refraction. So refractive index is given to be 1.5. So refractive index is 1.5. The angle of incidence is 60 degrees. So 1.5 is equal to the angle of incidence is 60 over sine R, which is the angle of refraction. So I'll cross multiply 1.5 sine R is equal to sine 60, 0.866. So over 1.5 over 1.5, 1.5 goes. Sine R is equal to 0.866 divided by 1.5. Answer is 0.577. So we are going to find now the inverse function. by saying shift sine 0.577 equals, so angle R is equal to 35.3 degrees. So that is the angle of refraction. Then part 2, calculate the critical angle for a ray of light in this glass. So the critical angle, it has this formula. Refractive index is equal to 1 over sine critical angle. So remember that the refractive index, it is 1.5. 1 over sine critical angle. So from there, I'll cross multiply. So over 1.5 over 1.5, this goes. Sine critical angle is equal to 1 divided by 1.5. It is 0.6667. So from there, we are going to find now the inverse function. Shift sine 0.6667. The answer is critical angle is equal to 41.8 degrees. Part C, explain why the ray shown cannot emerge from KL, but it will emerge from side LM. So this is the diagram. So this ray of light, it cannot emerge from KL, but it will emerge from LM. In other words, it will go like this. That's how it will emerge, but it will not emerge from KL. So what is the reason? So there, the reason is simple. The angle of incidence is less than the critical angle, allowing it to emerge from LM. So in other words, the incident on side KL, the incident on side KL at an angle which is greater than the critical angle. So this can cause the total internal refraction, meaning the ray is reflected back into the glass instead of reflecting out. Part D, diamond has refractive index of 2.42. The speed of light in a vacuum or in air is 300,000 kilometers per second. Calculate, number 1, the speed of light in diamond. So the formula that we will use here, it is for refractive index. So refractive index is equal to speed of light in a medium over speed of light in a vacuum. So in this case, refractive index is given to be 2 2.42 equals, we are looking for the speed of light in diamond. So that is the speed of light in a medium over speed of light in a vacuum. It is constant. It is 300,000, which is 3 times 10 to the power. So remember that this is 300,000 kilometer per hour. So I can change from kilometer to meter per second. So how do I change from 3,000 kilometer per second into meter per second? So follow me. So 300,000 kilometers over per second, meaning 1 second. So I will convert from kilometer to meters by multiplying with 1000. So what I'm going to have is 1, 2, 3, 4, 5, 6, 7, 8. So I'll have 3 times 10 to the power 8 meters over 1 second. Okay, so 1 second into there, it will give us 3 times 10 to the power 8 meter per second. So that is power 8. So I'll cross multiply. So 1 times x, it is x is equal to 2.42 times 3 exponential to the power 8. So the answer is 7.26 times 10 to the power 8 meter per second. Calculate the critical angle for diamond. Remember that the refractive index, it is 2.42. So refractive index is equal to 1 over sine of the critical angle. So refractive index, it is 2. 2.42 is equal to 1 over critical angle. So I'll cross multiply there. So I'm going to have 2.42 sine is equal to 1. So over 2.42 over 2.42. So what we have is sine I, which is the critical angle, is equal to 1 divided by 2.42. 0.4. So now the inverse function there, it is critical angle is equal to shift sine 0.4132. The answer is 24.4. So 24.4 degrees is the critical angle. C3. The atomic number of americium 241 is 95. Americium 241 decays by losing an alpha particle. A1. Explain why smoke detectors containing americium 241 are not harmful to people. So, they are not harmful to people because americium, it is emitting an alpha particle which has a very short range in air. Therefore, it cannot penetrate the human skin. It cannot even penetrate a sheet of what? Paper. So therefore, it is not harmful because it has a short range. So remember that alpha particle is stopped by a paper or even the skin or even the cloth. So part 2, copy and complete the equation showing this decay by giving values for x and y. Okay, so this is alpha decay. So remember that this one, it is emitting an alpha particle. So the mass number, it will be reduced by 4. Okay, so we are going to have 237. So 241 minus 4, it is 237. Then the proton number, it will be reduced by 2. So we are going to have 93. So that is the way it is. So the value for X is 237 and the value for Y, it is 93. So part B, figure C 3.1 shows how the activity of a sample of americium 241 changes over a long period of time. So this is time in years, this is activity counts per minute. So part 1, use these numbers to draw a graph of activity against time for americium 241. So the first thing is that you need to come up with a suitable range. So as you can see for time, which is the x-axis, so against time. So time it is x-axis, activity it is y-axis. So for x-axis we have 0 to 2000. So we have to choose a suitable range. Then there we have 2 to 64. So that is for the y-axis. So for the x-axis, I'll take 2 centimeters to 250. Then for the y-axis, I'll get 2 centimeters to 10 units. So you have to label the x-axis time in years. So we have 2 centimeters to 250. So that is for the x-axis. So from here to there, so how do we count? So we count 1, 2, 3, 4. That is 100. 1, 2, 3, 4. That is 200. 1, 2. That is 50. So we have 250. So 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. 1, 2. 500. Then we have 10, 20, 30, 40, 50, 60, 70. So for the y-axis, it is activity. So counts per minute. So from there now, I'm going to plot. So remember, you always start with the x-axis, you end with y. So x, we have 0. Then y, we have 64. So 0, 64. So 0, 60. So 61, 62, 63, 64. So you have to use a pencil. So that is 64. So you have to use a pencil. Then we have 500,30. So 500,30. So this is 500,30. And then we have 1000,14. So 1000, 10, 11, 12, 13, 14. Then we have 1500,6. So 1500, 1, 2, 3, 4, 5, 6. Then the last one is we have 2000, 2. So 2000, 1, 2. So our graph will move from here, it comes here, then it will end there. So you have to use a freehand. So this is the graph that we have. Okay. So the next question is, use your graph to find the half-life of... Do we use our graph to find the half-life? So now, remember the total activity, it is 64. So we are going to find the half of 64. So half of 64 is equal to 32. So we'll go on the graph where 32 is. So this is 30, 31, 32. So this is 32. I'll draw a dotted. Then from where the graph is intersecting with the line, I'll come downwards. So this is where it is intersecting. So this is where the answer will come from. So this is 250. So this is 250. 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. So 450 years is the answer. So remember the range that we are taking here. So it is these small boxes, 1, 2, 3, 4. That is 100. 1, 2, 3, 4. 1, 2, 3, 4. That is 100. 1, 2, 3, 4. That is 200. Okay, so this is 250. So 250 we have 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. So 450 years is the half-life. So the half-life, it is 450 years. And part C, Californium-241 is also radioactive and decays by losing an alpha particle. Its half-life of 4 minutes suggests why it should be unsuitable for use in a smoke detector. So Californium-241 is unsuitable for the use in a smoke detector because it has a short half-life of 4 minutes. So which makes it unsuitable for smoke detectors because it decays very quickly. So smoke detector would stop functioning within a very short period of time.